Is problem 3 on practice exam 4 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. We have a deposit of $10,000 into a bank account that earns 5% compounded continuously, an annual interest rate of 5% that's compounded continuously. There's the normal equation that relates the bankroll value to the time. If we plug in time equals 0, we get $10,000. So by estimating the slope of the tangent line at t equals 0, get the initial growth rate of the account in units of dollars per year. Let's start with the tangent line at time equals 0. Be bold all the way across. The run is easy. We're going to use that triangle. 25 years goes across the whole graph. Now I have to get the rise. Starts at 10,000. Goes up to, looks like, 22.5. So the rise is 12.5 from 10 to 22.5. And if we calculate the slope, we get $500 per year. The rate of growth is $500 per year. On to part B. Use the normal equation to determine the value of the account one day after deposit. The normal equation is, we just copied it down. Now we're going to stick in 1 day for t. Now we can't just stick in 1 because it's 0.05 per year. This has to be in units of years. 1 day is 1/365th of a year, forgetting about leap year. So B is this. The years cancel as they must because when you raise something to an exponent, the exponent can't have any units. It's a pure number. It has to be a pure number. So we do that on the calculator. We get $10,001.37. That's the value of the account after 1 day using the normal equation. The question asks, is it consistent with our answer to part A, which is $500 per year? So we have to see, is $500 per year consistent with this answer? So we have the slope. The slope is the rise over the run. We can pick a run, and our run is 1 day. We want to know the rise, the change in the bank account value after 1 day. So we want the units to cancel out, so we put years, and then we solve for delta B. We just multiply both sides by 1/365 of a year. We do that, we get $1.37, which is consistent. We got the same answer using the normal equation as we did using the slope and extrapolating 1 day away from 0. On to part C. Now we're going to go over here, 20 years. And we're going to go all the way to 21 years along the line. The normal equation is that all we do is stick in 20 years to get the bank account value. We plug it in, $27,182.82. In 21 years, we stick in 21 for t. We get $28,576.51. We subtract them to get the difference, and it's about $1,394, roughly. We can get as many significant digits as we want because these are exact equations. We're not estimating anything. On to part D. Part D asks us to use the difference equation, and they give us the difference equation. So here's delta B, here's delta T. This is how the bankroll changes in over some time interval, delta T, at T. So using this equation, estimate the interest earned from 20 years to 21 years. So there's the difference equation, just copied it down again. Now we have to plug in a T and a delta T. Do you know what these values are? If not, think about it. Stop the video and think about it. Make sure you understand what's going on here. It's hard. It's calculus. So the time will give the linear relationship between delta B and delta T for that time. The slope of the line for that time. The slope of the line is different at 20 years than it is at 0. If we plug in 0, we can get the slope at 0. If we plug in 20 years for t, we get the slope at 20 years. So we divide both sides of the equation by delta t. Delta b over delta t, this is the slope. And if we stick in 20 years, we get the slope at 20 years. The slope at 20 years, this dashed line right here, is 1359 per year. And our delta t is 1 year. We're going from 20 to 21. So if the growth rate is 1359 per year and our delta t is 1 year, the interest earned is 1359. That's our estimate. And we should expect that estimate to be low because the line is curved upwards and we're going along the dashed line. The actual interest is $13.94, so we're $35 low, but we shouldn't be surprised because we're using the tangent line. And we threw away the nonlinear part. If we included the nonlinear part, we would get the exact answer. So we invite you to explore further. Don't just do what's assigned and say, thank God that's over. So if you want, you can try to get the slope at 10 years. And then what's the interest rate earned in 1 day at 10 years? Do it until you say, I really know what's going on here. I see what's going on. That's the goal.